Section 6. File storage on a storage medium. Introduction. When a user saves a file to disk, he is not bothered how and where it is saved. It is the function of the operating system to save the file in such a way that whenever the user requests for the file, it can be retrieved. The file allocation table stores necessary information that will be used to locate a file. There are two main ways that the system stores files: contiguously and non-contiguously. The non-contiguous method can further be divided into chained or linked allocation and indexed allocation. Learning outcomes. At the end of this study session, you should be able to 1. Discuss contiguous storage, 2. Explain non-contiguous storage, 3. Discuss memory management. Contiguous storage. In contiguous storage allocation, records of a file are stored one after other. Single set of blocks are allocated to a file at the time of creation, so every part of file is stored in same compact area. See figure 6.1. The file allocation table contains information which states the starting block and length of each file. Any record can be found and read once the starting address and size are known. Because of the way file blocks are allocated in this type of allocation, external fragmentation will occur. External fragmentation is a phenomenon where there are slivers of unused storage spaces, block number 0, 1, 5, 29, etc. from figure 6.1 above, between sets of blocks belonging to different files. When this occurs, there will be need for the operating system to perform compaction. Compaction is rearranging several blocks of different files on the disk together so that they are closely packed, and then gather the unused blocks that were between various files. This is done so that there will be enough space which is large enough to accommodate other files. Contiguously, figure 6.3 shows the outcome of what will happen after figure 14 has been compacted. Disadvantages of contiguous storage. 1. Files can't be expanded unless there is empty space available immediately following the file. 2. Room for expansion must be provided when a file is created and may not be used. 3. Fragmentation occurs, that is, slivers of the unused storage space. 4. Compaction may take time. 5. Files can't be accessed while compaction is taking place. Non-contiguous storage. We have considered contiguous storage. Now, let us consider non-contiguous storage. Non-contiguous storage allows files to use any storage space available on disk. Files records are stored in a contiguous manner if there is enough empty space. Otherwise, any remaining records and all other additions to file are stored in other sections of disk. The two methods of non-contiguous storage are the chained, linked storage and indexed storage. 1. Chained or linked storage. In this method, allocation is done on basis of individual blocks. Each block contains a pointer to the next block extant in the chain. The file allocation table also stores information necessary for loading all the block of the file. This includes the starting block and the length of the file. Since the records of a file can be stored in any block and linked together, there is no external fragmentation and no need for compaction. This type of storage is best for sequential files. It does not support direct access because there is no easy way to determine the exact location of a specific record. Figure 6.3 shows what this type of storage looks like. From the file allocation table, you can see that the starting block for file B is block 1 and the file spans 5 blocks. So to load the file, the system starts from block 1. At the end of block, there will be a pointer specifying that the next block is block 8. This can be seen from the arrow. The system goes through and fetches all the blocks one by one to load the file completely. The linking can be at storage level, where each extent points to the next one in sequence. The directory entry here will consist of file name, storage location of file extent, location of last extent, and the total number of extents not counting first. However, if linking is at directory level, Each extent is listed with its physical address, size, and a pointer to next extent. A null pointer indicates that that block is the last one. 2. Indexed storage. In indexed storage, every file has its own index block which contains the addresses of each disk sector that make up the file. The index block lists each entry in the same order in which sectors are linked. When a file is created, pointers in the index block are set to null. As each sector is filled, the pointer is set to the appropriate sector address, and this address is removed from the empty space list. In this storage method, the file allocation table contains a separate one-level index for each file saved on the medium. This means that the file allocation table contains the block number for the index of a file. The index has one entry for each portion block allocated to the file. Figure 6.4 shows what this type of storage looks like. Indexed storage supports both sequential and direct access to files. However, it does not necessarily improve the use of storage space because each file must have index block. For larger files with more entries, several levels of indexes can be generated. To find the desired record, File Manager accesses first index highest level, which points to a second index lower level, which points to an even lower level index, and eventually to data record. Memory Management Operating Systems. In operating systems, memory management is the function responsible for managing the computer's primary memory. The memory management function keeps track of the status of each memory location, either allocated or free. It determines how memory is allocated among competing processes, deciding which gets memory when they receive it and how much they are allowed. When memory is allocated, it determines which memory locations will be assigned. It tracks when memory is freed or unallocated and updates the status. Memory management techniques are single contiguous allocation, partitioned allocation, paged memory management, segmented memory management. 1. Single contiguous allocation. Single allocation is the simplest memory management technique. The entire computer's memory, usually with the exception of a small portion reserved for the operating system, is available to the single application. MS-DOS is an example of a system which allocates memory in this way. An embedded system running a single application might also use this technique. A system using single contiguous allocation may still multitask by swapping the content of memory to switch among users. Early versions of the music operating system use this technique. 2. Partitioned allocation. Partitioned allocation divides primary memory into multiple memory partitions, usually contiguous areas of memory. Each partition might contain all the information for a specific job or task. Memory management consists of allocating a partition to a job when it starts and unallocating it when the job ends. Partitioned allocation usually requires some hardware support to prevent the jobs from interfering with one another or with the operating system. The IBM system /360 used the lock and key technique. Other systems use base and bounds registers which contain the limit of the partition and flagged invalid accesses. 3. Paged memory management. Page allocation divides the computer's primary memory into fixed size units called page frames and the program's virtual address space into pages of the same size. The hardware memory management unit maps pages to frames. The physical memory can be allocated on a page basis while the address space appears contiguous. Usually, with paged memory management, each job runs in its own address space. However, there are some single address space operating systems that run all processes within a single address space, such as IBM I, which runs all processes within a large address space, and IBM OS/VS2 SVS, which run all jobs in a single 16 MIB virtual address space. 4. Segmented memory management. Segmented memory is the only memory management technique that does not provide the user's program with a linear and contiguous address space. Segments are areas of memory that usually correspond to a logical grouping of information such as a code procedure or a data array. Segments require hardware support in the form of a segment table, which usually contains the physical address of the segment in memory, its size, and other data such as access protection, bit and status, swapped in, swapped out, etc. Summary. In study section 6, you have learned that 1. In this type of allocation, records of a file are stored one after the other. Single set of blocks are allocated to a file at the end of creation, so every part of file is stored in same compact area. 2. Non-contiguous storage allows files to use any storage space available on disk. Files records are stored in a contiguous manner if there is enough empty space. Otherwise, any remaining records and all other additions to file are stored in other sections of disk. The two methods of non-contiguous storage are the chained, linked storage, and indexed storage. 3. In operating systems, memory management is the function responsible for managing the computer's primary memory. This is the end of study section 6. Thanks for listening.